Okay, I am back. Well, I'm not really back. I'm in sunny California, but you know, remember, there's a lot of smog there, so you guys are a lot happier, better off than being down with me. So let's take a look at today's lesson. So we're talking about linear functions. Linear means straight lines, okay? So today our topic is how to graph and solve linear, sorry about the horrible handwriting, linear functions. There's the bell again. Today's date, 9/21. Okay, so first of all, if it's linear, it's going to be straight. So what's going to happen is that the rate between things never changes. So let's take a look at the first example. Let's see, I'm going up by 2, up by 2, up by 2. So every time I go over by 2, I'm going up by 3, up by 3, up by 3. That's pretty consistent. Every time I go up 3, I go over 2, up 3 over 2, because this is my y's, my x's. So it's got to have a consistent slope. So I'm just going to write that down. The slope in this case is up 3 over 2. So yeah, that's linear because it's consistent. See how consistent it is? It goes up by 2, up by 2, up by 2, then up by 3, up by 3, up by 3, okay? Let's look at the next example. Let's see if it's different. I go up by 3, up by 3, up by 3. Okay, every time I move over 3 on the x, every time I move over 3, I'm going to go up 1, then I'm going to go up 2, go up 3. No, that's not linear because you're going up by more. It has to be consistent. As I go over 3, over 3, over 3, I go up by 1, then I go up by 2, up by 3. No, that's not linear. That's curvy. We're going to find out what that is another day, but no, that is not a linear function. It's a function, but it's not straight. It's not linear. Okay, example 2. Find the equation line and graph it if it has a slope of 2/3 and it passes through the point 1, 1. All right. So point 1, 1 is here. And if it has a slope of up 2 or 3, that's my slope. Slope is always rise over run. So I go to my point 1, 1. I'm going to go up 2 over 3. Up 1, 2 over 1, 2, 3. I'll go down 1, 2 over 1, 2, 3. There's the bell again. Okay. And I get this line right here. Now what's the equation of that line? Well, we have an equation of a line. We really do. So the equation line I like to use is this one. It's called y minus y1 equals m times x minus x1. Okay, that's the equation line. It's on the back wall. It's up above the window. It's always there. Okay, so y and x are variables. They're going to stay y and x, but y1 and y1 and x1 represents my point. So my point's an x, then a y. So this is my x1 and this is my y1. So I'm going to do a little bit of plugging in. I'm going to take and plug in my 1, 1 in for my x. And I'll take my 1, 1 and plug it in for my y. Okay? So here's how it works. I'm going to go y minus 1. My y variable minus my y1 value, which is 1, equals m. Now the slope I know is 2/3. 2/3 x minus x1, which is 1. Okay? So I put the y1 value here, which is the 1. I took the x1 value, which is the 1. I plugged it right there. Okay? Now I'm going to simplify it. And of course the m is the slope, which is 2/3. All right. So I get y minus 1 equals, I'm going to distribute this times this times this. 2/3 x minus 2/3. And then I'm going to solve and go plus 1, which is going to give me a positive 1/3. So my answer is y equals 2/3 x plus 1/3. Kind of looks like it. Looks like you've got a y-intercept of 1/3, and then it goes up 2 over 3. Okay. Example 3. Find the intercepts and graph it. Now this is actually pretty good. So if you want to do the intercepts, let's first talk about the x-intercepts. X-intercepts. Well, any line that has an x-intercept would have to go through the x-axis. Okay? So if it goes through the x-axis, then it would have to have a height or a y value of 0. So to find the x-intercept, let's let let y equal 0. Alright, so let's go over here, go 2x plus, whoops, sorry, 2x minus 3 times 0 equals 12. And of course that's just 0. So you really get a 2x equals 12 or x equals 6, right? So I let y equal 0. I get 2x equals 12, so x equals 6. So let's put a point at 6. 1, 2, 3, 4, 5, 6, okay? So that is a point 6, 0, okay? Well, it's got another intercept. That's an x-intercept. It also has a y-intercept. And the y-intercept is going to be when x is 0. So y-intercept, let's let x equal 0. Okay, I can do that. So let x equal 0 here. 2 times 0 minus 3y equals 12, right? Of course, that's just 0. So I get minus 3y equals 12, or y equals negative 4. All right, I can do that. 1, 2, 3, 4. And that's a point 0, negative 4. Okay, so put a dot there. Now to graph it's super easy, isn't it? Just connect the dots. Well, it can also be described in slope-intercept form. So one of the ways we can get it in slope-intercept form is from the graph, or we can solve for y. So to get it in slope-intercept form, we're going to solve for y. Alright, 2x minus 3y equals 12. Right? So I'm going to subtract or bring over the 2x. I'm just going to bring it over. So the way I bring it over is by subtracting it, right? I have to bring it over because I want to get y by itself. So subtract the 2x. Go minus 2x, bring it over. I'll have a negative 3y equals a negative 2x plus 12. Because I just subtracted the 2x. Okay, I just didn't show that, but I could have gone minus 2x, minus 2x. I like the x in front. Looks better. Divide by negative 3, right? Divide by negative 3. Let's see what I get. Y equals positive 2/3 x minus 4. Okay, check it out. I think that's right. Because if I look at my graph, start at negative 4, up 2 over 3, up 2 over 3. Wow, it works. Amazing, huh? Okay, so let's turn the page and see what we got there, okay? Okay, example 5. So y equals 3. How do you graph that? Well, think about this. Here's my y-axis. And here's a height of 3. This is a y value of 3. This point right here has a y value of 3. This point right here has a y value of 3. A y value of 3, a y value of 3. So it's going to be a horizontal line at y equals 3. So if you ever have a y equals just a number, it's going to be a horizontal line. And the slope has to be 0, because we're going up 0 over 1, up 0 over 1, up 0 over 1. Okay? Now, example 6. X equals negative 2. Well, here's my x-axis, right? And here's negative 2 from my x-axis, right? And if it always has a negative 2 value, here x has a negative 2 value, negative 2, x is negative 2, it goes straight up and down. X is always, all of these points always have x equals negative 2. Okay? Okay, the only problem with this graph that I don't like right at the bat is it's not a function. Remember? Not a function. Okay? It's not a function. Remember, this isn't going to pass the vertical line test, and an x value has way more than one y value, so it's not a function. So what's the slope? There is no slope. We'll say the slope is undefined. Okay? Alright, that's not bad. So this is a vertical line. So if it's y equals a plain old number, horizontal, slope is 0. X equals a number, vertical, undefined because it's not a function. Okay, last one, example 7. Okay, a road rises from 2,500 feet to 7,000 feet in 10 miles, okay? So find the average slope of the road. So it's going to have to be, obviously, feet to miles. So here's the problem I've got, is this is in terms of miles. So if we can get the same axes, that would help a whole lot. So what I want to do is this. I know there's 5,280 miles, I'm sorry, feet, feet in a mile. I'll say that again, sorry to mess up. 5,280 feet in a mile, okay? So if I do everything in terms of feet, and then I have the elevation gains in terms of feet, right? So we're going to rise from 2,500 to 7,000. So let's see if we can do this, okay? So what I'm going to do is try and do it as a slope, okay? Now what I know about slope, it's rise over run, okay? So I'm going to go from 7,000 minus 2,500 in 5,280 feet, okay? So I went from 2,500 to 7,000. Now the reason I'm subtracting is I want to know how much did I actually gain. So if I subtract this from this, I'll know how much I gained in 1 mile. About 10 miles. So let's add another 0, okay? Alright, because it's in 10 miles. I'm going to multiply that by 10. So 7,000 minus 2,500. Do that. 7,000 minus 2,500 is 4,500 feet divided by my 52,800. So if I divide that, I'll get about 0.08. Now that's how much I gain in a mile, right? Which is not a whole lot of feet in 1 mile. But it's a gradual thing, all right? Or you could divide it the other way. 5,800 over my 4,500. And I can answer about 11.33. So you can 11.73. So there's another way to look at it. You can say that you're gaining this many miles per feet, this many feet per elevation. I'm not saying it right. This many feet per elevation. Okay, homework today, page 110. I want you to write the question, show the work, don't forget to show the work, and graph it. Okay, that's all I have.